So this morning we will work on Scratch programming. Yesterday we studied computer science with unplugged activities, and so today we will see that computer sciences are also made of programming. The purpose is to use an easy-to-use interface with Scratch and to learn how to build an algorithm, how to build a program, how to build a small video game. To exchange with each other when you will have complex tasks to do for programming. It's far better to be two people than to be alone in front of your computer. Okay. So everybody have Scratch launched on the laptop? Yeah?
Yeah.
One, yeah, so
Phase one.
yeah, but two, you should have three computers. Yeah, but this one is working. So, okay, so anyway, you will work with one computer for three people. Scratch everywhere is okay? No, it's not okay. Can you launch Scratch? Did you install it? No, you didn't install it. You download it, but you didn't install it. So please, another computer. I will not take time for installation. Yeah, okay. That's okay. That's okay. Is it okay? You have Scratch? Okay. Scratch. Scratch. You don't have time and you don't need it. No, please. Okay. And is there any other computer with Scratch here on the table?
We also got
This one has Scratch installed. So, do you have Scratch on this computer?
Yeah.
Not yet. Okay. 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 So, let's start by three people on one. Scratch is not installed? Okay. So let's start with three people for one laptop, because otherwise we will lose at least 1 hour in order for everybody to install and fix and so on. So I don't want to do that. Okay. So who ever experienced computer programming?
Oh, computer programming. Still.
Yeah?
Yeah.
You did some computer programming?
Yeah, I did. I attended a course about Sprite, but I'm not so good at it.
Okay. Okay, so you make some programming, but using Scratch. Okay. Has any one of you ever programmed a computer without Scratch, with let's say C or
Long time ago,
Peter?
they did.
Yeah, a long time ago.
Long time ago.
Okay. Okay. So one of you has ever programmed a computer. One of you attended a course on Scratch, but the other people, for you, it's the first time you see Scratch.
Yeah.
Okay. Did you play a little bit with it yesterday evening, or no?
We went to sleep early.
Yeah. It's a good idea.
Yeah.
Good sleep, good breakfast, remember, it's a good idea. Okay, very nice. So let's start with the basics. Yesterday we spoke about the fact that computer science needs special languages in order to be understood by the machines. There are approximately 2,000 different languages for programming. So some of them are very efficient for certain tasks, and some of them for other tasks. For education, there are few dozens languages, and to my opinion, Scratch is by far the best. It's not the only one, of course, but I think it's the best one for a lot of reasons. First of all, it has been designed explicitly for education. It's not designed for making video games or programs. It has been designed for learning how to program. The interface is very simple. Here you can see it's divided, let's say, into 4 parts. Here, the scene is where the action takes part. Here, when you launch the program, you have a cat. Okay. But you can have a lot of objects, living or non-living objects. You can have cars, people, animals, things, letters, whatever you want. They are called sprites, these objects. And the different sprites you have will be listed here. You can have as many sprites as you want. Each sprite, each object has its own program. And the program of this object is here. This is the place where we build the program. And for writing a program in Scratch, it's very simple. You take instructions that are here, and you move instructions here, and then it works. It's very easy. You don't have to learn for any special word, because everything is completely intuitive. When the instruction is move by 10, okay, so the cat will move 10 pixels. Okay. Turn 90 degrees, of course, it will make the cat turn 90 degrees. So it's very obvious. You don't need to learn specific actions. It's completely transparent for you. You don't need to learn grammar, because the only actions you can do are the actions that have sense. Things that don't have the meaningless are impossible in Scratch. So you don't. It's impossible to make a mistake with the grammar, with the syntax, etc. For a little demonstration, how it works, you will see that it's very simple. So if you want to change the language, it's here. It's available in a lot of language. Here I will do it in English, but if you want in Chinese, in Farsi, in Arabic, in whatsoever, or in French, it's possible. Okay? So it's also a good point for education. I will zoom here. So move 10 steps. I take the instruction here and I put it here, and then when I click, the cat moves 10 steps. Okay? If I say turn 15 degrees, he will turn 15 degrees. But the power of that is that I can attach the different instructions, so it's a sequence. And if I click at the top, he will both move 10 steps and turn degrees. But I can also use events. For example, when I click on the red flag is here. The red flag launches the program. And here, the stop button, of course, stops the program. So when I click on the red flag, green flag, excuse me, it works. But I can do it, I can say repeat 10 times this. And so when I click on the green flag, okay, I can say repeat forever instead of repeat 10 times. Oops. Let's stop the program, and when I launch the program, okay, it will repeat forever these actions. Okay. So this is very simple. So let's do some basic exercises. But before I give you some exercises, take 5 minutes to play a little bit with that, to discover. You will remark that there are a lot of different instructions here. Instruction connected relative to motion in blue, looks, sound. I ask you not to use this functionality, because with 20 people in the room, if everybody plays sound, it will be terrific for us. Pen, data, we will see it after. Event, control. That's a good start. Mark that Scratch scene is organized that way. I mean, the sprite has coordinates. Here, it's the center of the scene, and the coordinates are 0, 0. Here, this is the x-axis. Here, x is equal to minus 240 plus 2 minus 40. Y minus 180 plus 180. I will just, okay? This kind of representation is not supposed to make problems for you, but so is it okay? So when you say go to 0, 0, it means go to the center of the scene. If you say go to 0, 100, for example, it will be here, or 100, 0 here, minus 100, 0 here, etc., etc. Okay? So this is how the coordinates work. Now, few exercises, it will be very, very simple. You will see. So, make the cat advance by 20 steps, meaning 20 pixels. There are dozens of ways to do that. But find 1 or 2 ways. Okay? You will see that when we build programs, there are always a lot of ways to do the same task. A lot. Some are very elegant, some are quite odd, but it's very, very easy. Okay, so somebody wants to do it on my computer? No? So, move 20 steps.
We make command 20 steps, but it shows only 1 step.
No, yeah, okay. You have to click here on the sprite, because here you are trying to program the scene, not the sprite. Click on the sprite, and now you have. So, nobody wants to, okay, please. You will do it on my computer, or please? Yeah, excuse me. Excuse me. Okay, so just look at that. If you want to remove a program, you take the program and you put it here, it disappears. Okay? So.
New file.
No problem, no problem.
New file.
So move 20 steps. There are different ways to do that. Yeah, sorry. It's a French keyboard. You have to click on Shift for. Okay. So now, if you click on it, if you click here, is it working? Yes, it's working. Yeah, you can add this. Okay. Okay. Nice. Thank you.
Okay.
For the next exercise, I would like you, for the common discussion, to come with your computer. It will be easier because it's a French keyboard, and for you it's quite strange to use. Okay. So, second exercise, which is, oh no, sorry. I said there were a lot of ways to do that. Did you find the other way? It's moving one step and stop.
Is this glide to the coordinate?
No, just with the move.
Oh, move.
But it moves once and then stops.
Did you find how to do that?
Yeah, we have it, but it's disappear from the screen. It's not.
100 pixels. If you say 20 pixels, it will move 20 pixels.
So it's just the distance, right?
Yeah.
Not the step.
No, it's not.
We will
Yeah.
try to count
Yes, yeah. Okay. No, sorry. No, it's not really steps. It's a distance. So your program was perfectly correct. Okay. So another way to do that is, for example, to say move 10 steps, and then I will make a right click, duplicate, move 10 steps. This is exactly the same. Okay? Another way, but it's not very elegant. Huh? Another way to do that, for example, is to say move 1 step and repeat it 20 times. It's really not elegant, okay? But it works. Okay, so there is always a lot of way to solve a problem when you program, but of course, the simplest method is the best one. So the best answer here is what you have done, move 20 steps. Okay. Second exercise. Put the cat at the center of the scene. When you click on the red flag, the cat should return to the center. Remember the coordinates system. Is it okay for you?
To the center of the.
So,
This one is not working.
yeah, but it's so. Can I take it in order to install Scratch on it? So is it okay for everybody? Can someone on this table come and make the demonstration here? Please. Please, we have to be quick here. So return to the center of the screen.
Yeah, where that's instruction, how to make this cat.
Okay, so how to do that? Let's say when the green flag is clicked, I will go somewhere, and where will I go? I will go to the center of the screen. The center is 0, 0. So if I click on the green flag, oops. Okay, it's very simple. Is it okay for everybody? Yes. So another exercise. Repeat 3 times when you click on the green flag. Repeat 3 times, advance by 20 steps, and say hello. Say meaning write, not say with sound. Okay? Say hello. Some people have made this program. What do you think? Move 20 steps and repeat 3 times. Say hello. It was not what I have asked to do. I have asked to. Some other people have made this. Repeat 3 times. Move 20 steps. And after that, say hello. And some other people have made this. So remember the exercise was repeat 3 times, advance, say hello. Okay? So which program corresponds to the exercise? This one? Yeah, exactly. Repeat 3 times the 2 instructions. Okay? Here, I first move 20 steps, and then I repeat 3 times, say hello. Here, I move, no, sorry, what I have, yeah, I move, then say hello, and here, I repeat 3 times, move 20 steps, and say hello. But when I click, I have the feeling that it happens only once. Let's do it. It doesn't seem to happen 3 times. But in fact, this is because it happens very fast. If I want to control this, I can use here control. I will wait a little bit after each loop. Let's say I will wait half a second. And then I will see that effectively it happens 3 times. But hello, hello, hello. Oh. Okay? But as it is very fast, if I wait 0 seconds, as it is very fast, I have the impression that it happens only once. But in fact, it happens 3 times. I can wait 1 second if you want. Okay? So this is something that is really important when you make programming. A lot of time you have bugs or odd things, and one of the best way to correct and to identify your bugs is to make some pause in the program, like this one. Okay? So now, repeat forever, advance, let's say 10 steps or 20 steps, what you want, and change costume. Change costume, you will see that the cat can have different appearances, and you can change costume. So please do that. So look at her program.
But cannot be seen then. Still cannot be seen, David. So
Yeah. Click. Okay, so click once again. So stop it. So what does the program do? At first, it asks the cat to go here. And then it repeats forever, move, change costume, and wait a little bit, because if you don't insert this instruction, it happens so fast that you don't see anything. Could you please click here?
Where? Here?
Costumes. So you can see that the cat has 2 different costumes. You can create dozens of costumes if you want, or just one. But here the cat has 2 costumes. So when you alternatively change costume, you have the feeling that he's walking.
Oh.
Okay? This, 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 this. So when you return to script, or maybe wait 1 second or half a second here. Yeah. No, costume is not a dress. It's the appearance of the sprite. Okay, and click on the red flag. And now see what happened. Okay? So it's not very natural way of working, but if you make it faster, for example, by waiting just 0.1 or 0.2 second, it will give the impression that it is working. Okay? Okay. So now you've got the very basics about Scratch. The sprite, you can have as many sprites as you want. One sprite can have as many costumes as you want. Each sprite got its own program. And for building a program, it's very easy. You just have to take instructions here and to put it here. Okay? So now we will come back to our project, which is to build the video game I have showed you yesterday. Okay. If you click here, you've got the scene full screen. Okay? So you can't see the program anymore, so you can't see the solutions of what we have to do. And let's remind what we would like to do. At first, when I launched the program, there are a lot of different sprites on the screen. But with my keyboard, I just control one sprite, the rover. So when I click on the right arrow, he moves on the right. When I click on the left, he moves on the left, down, up, etc. When I disappear here, oops, because my planet is a sphere, it's not flat. So when there is no border, of course. So when you disappear here, you appear here. But it's much more difficult. So maybe we will not do that. But it's not very difficult. But when I touch one resource, I'm sorry, it's in French, but here is the number of life. I will change the name of the variables, but here is the number of life. Here is score. Is it? Yeah, it's the same in English. Okay, so no problem. And when I don't have life anymore, game over. Game over means that all the sprites disappear, and game over appears. And you can't do anything more. So, and there are a lot of other things that happen in the program. When I touch a resource, the resource disappears, and it appears somewhere else randomly. Oops. Okay. So you have to say, okay, when it is click, disappear, reappear, but not at the same place, somewhere random, but not completely random. Whoops. Each time my score rise up, each time my score increases, the tornado becomes bigger and bigger and bigger, and it moves faster and faster and faster. And the direction of the tornado is completely random. So I cannot predict it. So there are a lot of things here. We have to manipulate events. What happened when I click on the keyboard? We have to manipulate variables, the score, the number of the lives of life, the speed of the tornado, etc., etc. We have to manipulate other events. What happened when I touch the lava or the tornado is game over directly, but for dune here or lava, it's just one life less. Okay. So there are a lot of things to do in this program, and when you will achieve it, basically you will be able to program anything, because all the principal concept of programming, you will manage it. I don't want to show this. Okay. So here you can't see it. So now try to identify the different steps that we have to do to achieve this game. What do we have to do?
First, you start with your sprite.
First,
The backdrop, your sprite, all the sprite, you must have your sprite.
yeah, first we have to, we have to have some sprites on the screen. There is no pen. Okay. Never mind. First, we have to create at least one sprite at the beginning, the rover. It's not the cat. The rover, you can do what you want if you don't want a rover. You will see that in Scratch, there are a lot of predefined sprites. You can find animals, objects, cars, or planets, or what you want. So you have your rover or your main sprite. What do we want this sprite do? The second step.
Define the movement.
Yeah, define the movement. So we have to learn how to control it with the keyboard. What happens if I click on the right arrow, on the left arrow, etc., etc. After that, what do we want to do?
You define like what happens when it touches when it goes to the lava, what happens?
Okay, so we will create a new sprite, lava or whatever trap you want. Okay, it can be a ghost or a monster or lava. You define it, and when it touches it, it happens something. So the number of life decrease, so you need a variable, etc., etc. Okay, so if I try to sum up the main steps of the project are the following. So define the graphics, the scene, the sprite, and so on. Learn to guide the rover or whatever replace the rover in your program. Import the resources and the traps. Manage the number of lives. So if a trap is touched, life becomes life -1 and return to base. I don't remember, I don't know if you remember it, but when I touch a trap, the rover goes to the center of the screen, where there is the base. Manage the score, so if a resource is touched, the score increases, and the resource reappears somewhere else, randomly. And the game over when there is no life anymore, everything disappears, and game over appears. And if you are a very good programmer, maybe we will have time to program the tornado. It's much more difficult. Okay? So, let's do it. So let's do it. So you're not obliged to have exactly the same graphics that I defined. And I propose you that you personalize your game. If you don't want a rover on a planet, you can take a fish in the ocean. You can take whatever you want. The importance is that you need one main character, rover, car, animal, what you want. And you need traps. For example, if your main character is a fish, the trap can be a shark, let's say. And you will need some resources. Gold, coins, little fish to eat, whatever you want. Okay, so first define your graphics. Import one scene and one sprite. But before doing that, delete the cat. For deleting the cat, you make a right click on it. And you will right delete. Yep. And now you have to create a new sprite, and you will see that there are 4 different ways to create a new sprite. I propose you that we don't lose time. So for creating a new sprite, you can do different way. Here you can import predefined sprites that are already in Scratch. This is what I propose to do. You can also design your own Scratch by drawing, but we are not here to learn how to draw on the screen. So I propose we do not do that. We will lose time. You can import the sprite from a file. You can take your photograph or what you want. And you can take a picture if you have a webcam, etc., etc. So I propose here that we import a new sprite from here. And you will see that there are a lot of predefined sprites which are categorized here as animals, fantasy, letters. Letters would be useful, for example, for game over sprite. People, things, transportation, etc. So you choose one sprite. And for the scene, exactly the same. You can import a predefined scene in Scratch, design your own scene, import a photo, or take a picture with your webcam. So I propose also to use this one. And there are a lot of different predefined scenes, indoors, outdoors, or the OK. So you choose what you want. So the theme of your game will not be the same for everybody. Now here you are exploring Scratch online. This is not what we are doing. Please return to Scratch. You don't have Scratch installed on your computer? You don't have Scratch on your computer? Okay, so you use it online. Online. Here. So you will go to Create. Here. Okay, so it's supposed to be finished or almost finished. Right, left, up, and down. So first you have to detect when you click on a specific key. So it's an event we can do here and say, okay, when the key, whoops, when the key, not space, but let's say right arrow is pressed, then what? Then first orientate in the direction of right. Okay. First orientate in the right direction. Yeah. When I zoom too much, it's a small bug in Scratch. It doesn't want to attach. Okay. Look at right and then move. Sorry. Look at right and then move. Here it works. If I want to do the same for left, duplicate. And then I just have to change. So it's not right arrow, it's left arrow. And I don't have to look right, I have to look left. Is it working? So for right, it's still working, and left, it works, but it's quite bizarre. Okay, but we will solve it in 1 second. For this, you have to precise in the sprite definition how you have to behave when he changed direction. So it's here, formation, rotation style. I will change my rotation style and say, okay, just move in this axis only. And it's not a problem anymore. Okay, so it's a small tip to find. So now, if I want to do the same with the up arrow or down arrow, for up arrow, point up, and move 10 steps. And then the same for down arrow. I have to point in the direction down and move. So now I'm able to guide my sprite. Is it okay for everybody? So what I have done here, I have defined a style of rotation. I could have done it with the program.
How to make it face the way it's moving?
Sorry?
Make it face the way it's moving.
Make it?
Face and the direction it's moving. Like it's moving up,
Yeah.
facing left, so unnatural.
I'm sorry, I don't understand. What do you want to do?
Make the cat face up when it goes up.
Here it will work, but there is this problem. So I prefer I prefer this one. Okay? Otherwise you can try here. What happens? Here there is no rotation at all. Okay? Oops. This command can be also defined here. Set rotation still, left, right, don't rotate, or around. I could have done it that way, but sorry. I prefer here not to use this instruction, but to define it in my sprite by clicking here. Okay, so is this step okay for everybody? Okay, so I will put some order in my program. So now, what's the next step? Guide the rover, it's okay. Import resources and traps. So let's do it step by step. So I will just import a trap, for example. And I would like my cat to have 3 lives. And each time he will touch the ghost here, he will lose 1 life. So how to do that? What do we need? What do we need for managing the life of the cat? How to count the life of the cat? What in the program? Okay. If the sprite touched the other sprite, then something happened. Okay, but if what? Then what?
Then go to base 0, 0.
Yeah, but I would like the number of life to decrease. So how to manage life in the program? Scoring or life. What is it? Yes, it's a variable. It's a variable, and in Scratch, for create and manage a variable, it's in the orange script, data. So here I will create a variable. I will name it life. And now I got a variable which value by default is 0. But I don't want to start with 0 life. I want to start with 3 life. So how to do that? remark that if I click on this box, I can hide or show the variable. Okay? So here my variable is equal to 0. I want it to be equal to 3 when I launch the program, meaning when I touch the green flag. So how to do that? Please take 5 minutes to do that.
Set the life to a certain number.
Yes. You have to set the life to a certain number when you click on the green flag.
Yeah.
Yeah, for example, 3 or 10 or what you want. Okay? Okay. So remember that creating a variable happens here in data area. I create a variable and I already created it. Its name is life. So what I want is when I click on the red flag, on the green flag, is to make my variable equal to 10 if you want. So it's very simple. Set life 10. Oops. So now if I click on the green flag, my variable is equal to 10. Okay? I don't want to create 10 sprites here. It's not the way we will do it. The way we will do it is just to create a variable and to give a number to this variable. So now I would like this variable to decrease when the cat touches the ghost. So is it an event, for example? In events, we have when the flag is clicked. It's not that. When a specific key is clicked. It's not that. When the sprite is clicked, for example, when I take the mouse here and I click the sprite, it's not what I want. So there is nothing here that can help me. So maybe in sensing, I've got something here. When something touches something. So, for example, touching ghost for me. So remember that creating a variable happens here in data area. I create a variable and I already created it. Its name is life. So what I want is when I click on the red flag, on the green flag, is to make my variable equal to 10 if you want. So it's very simple. Set life 10. Oops. So now if I click on the green flag, my variable is equal to 10. Okay? I don't want to create 10 sprites here. It's not the way we will do it. The way we will do it is just to create a variable and to give a number to this variable. So now I would like this variable to decrease when the cat touches the ghost. So is it an event, for example? In events, we have when the flag is clicked. It's not that. When a specific key is clicked. It's not that. When the sprite is clicked, for example, when I take the mouse here and I click the sprite, it's not what I want. So there is nothing here that can help me. So maybe in sensing, I've got something here. When something touches something. So, for example, touching ghost for me. But I have to say, okay, if I touch ghost, then life reduce. So if it's here, if something, then something. Check. If the ghost is touched, then what? Life decrease.
By 1.
So change life by. If I change life by 1, let's do it. I click. Sorry. I will do it here. Look at the value of life. It's written here. Each time I click here, it increases. If I want it to increase 10 by 10, okay? But I want it to decrease, so it's -1. Sorry. -1. And now it works. Okay, so if the ghost is touched, then change life by -1. But it will never work because this is attached to nothing. So for example, I should say, okay, this will happen here. Do it and tell me if it works. If something touch something. If your ball, beach ball, yeah, touch what? Is the ball touch? Touch the beetle, then. So remember, we have a lot of things to do. We have done this, and we are okay. If I touch a trap, then life decreases, and I return somewhere else, to the base, 0, 0, or wherever you want. So now you will do the same, not exactly the same, but very similar, with not a trap, but a resource. So you have to create a new variable, which name will be score, for example, or points, or what you want, and a new sprite, which is not a trap, but a resource. Let's say a cake, gold, what you want. Sorry, a meal, what you want. And then when your sprite touch the resource, the life, nothing happens with the life, but the score increased by 1. Okay, so this will be very similar to what we have done, but with another sprite and another variable. Okay, so let's do it. We are here, manage the score. If you didn't manage to do that, please call me now. After that, if you're not ready for this part, call me now, because otherwise you will be completely blocked until the end. Okay? So if you have finished this, you are doing the other step. If not, you call me. Okay?
Yang ni kita miss tadi, event tu. The event.
Resource, let's say food, and to say, okay, when I touch food, bananas, then, I have to create my variable. My variable is score, and then okay, so 3 sprites. One, if I touch, I lose 1 life, and the other one, if I touch, my score increases. Okay. The game is more funny if the trap moves. Otherwise, it's too easy. So some of you have already done that. For the ghost here, I said, okay, I will move forever randomly. And this instruction is nice. Randomly means here in operators, I pick a random number. But in order for the sprite to move to the whole screen, I should do that. Okay, so now the game is much more difficult because, whoops, I have to avoid the moving ghost, okay? The last thing is to manage the life so that when life comes to 0, the game is over. We have seen few minutes ago one way to do that, but there are a lot of ways to do that. But at some point you have to make one test. If life equal to 0, then something happens. I will just show you how we say if life equal to 0. If something equals something, if life equal to 0. Okay? If life equal to 0, then game over. There is a lot of different ways to do game over. Some way is to make the cat say game over, but it's not really funny. For the game really to end, it's better for all the sprites to disappear completely and a new sprite, which costumes is game over, to appear. So for creating a new sprite with game over costume, I will go here. I pick some text. I have a new sprite. The text is awesome and not game over, but I can change it very easily. Now my sprite is game over. I will rename it. It's game over. This is the name of my sprite. Okay? So now what I would like to do is game over. It should be hidden when I launch the program. It should only appear when the program ends. So when it is clicked, the game over sprite hides. But when I, sorry, where did I put? Yes, this program is useless here. I will just move it here. And then if life is equal to 0, then show. And I have to make this test forever. So here, oops, game over. So it's almost finished. It will be finished when I will say to the other sprite to hide when it's game over. This one has to be hidden at the beginning and shown at the end. But the other one has to be shown at the beginning and hidden at the end. Okay? So I'll let you finish this program. Another way to do that, instead, if you don't want to make a forever loop, you can say wait until life equal to 0 and then show. Maybe it's more elegant that way. It's much more simple. Okay? So you have to modify the scripts the programs of your different sprites in order to make exactly the opposite. Show at the beginning, wait before game over, and when game over, hide. So it should take you 5 minutes to do that. Don't forget sometimes to save your program here, file, save. Otherwise, everything you have done will be lost. Of course. Okay? Oops. Yeah, I don't show the solution. You have seen it, but if you want to redo it, you have to think a little bit and not just to copy. Oh, you can write it this way if you want, but you can also type text. Here, type text. Text, and you write game over. One tip that is very convenient. Oops, sorry. Instead of checking everywhere, imagine you have 50 sprites. You don't want to make 50 times the same test. If life equal to 0, then etc. So maybe it's better to do the test only once and then send the message to the other. So here, this is where it happened in my program. I said, okay, this is, I initiate my variables, and I say, okay, do nothing else before life is equal to 0, and when life is equal to 0, I send the message, and the name of the message is game over, for example. It happens here. I have defined a new event, a special message that I create. When life equal to 0, I create a message game over, and for example, here I said, at the beginning you hide, and when you receive the message game over, you show. And here, at the beginning you show, and when you receive game over, you hide. The same here. At the beginning you show, when you receive game over, you hide, etc. And the program is much more clear if you do the test only once. And of course, if you have to correct it, if you make a mistake, you just have to correct one program instead of 50 programs, for example. So it's better to do that way. But there are a lot of functionalities that we didn't explore. But remember that we just have played with Scratch during 3 hours. For the complete process to do in the class, for the achieving really the game until the end, it needs 6 to 7 hours with kids. And it works perfectly well, even with 8-year-old or 9-year-old kids, but you need 6 to 7 hours to do that. Here we have done it quickly. Everything is dense during this week. This is the problem when we make workshops. We have a very limited amount of time, and we want to do a lot of things. So we condense, okay? So it's normal if you have the impression that we are quite fast, okay? We hurry a little bit, but don't worry, in the class, it's much more easy than what you have experienced here because you can take more time. Other functionalities we didn't look at is the pen, which is very nice. I will draw an example. Another program. Not this one. a new program. I want my cat to draw a square, for example. A square, so I will say, okay, you will move, oops, sorry, 100 steps, then turn how many degrees for a square? 90 degrees, of course. And then I will repeat that how many times? 4 times, of course. There is a way much more elegant to repeat 4 times things. But here I just check that. Oops. Why? What happened here? Move. Well, I don't know what happened, but let's say I prefer this one. Okay. But here I don't see the square. I will make a bigger square in order for you to see it. Well, it's a bit too much. Okay. Slow, okay, we can slow it down. Wait 1 second between each movement. Tuk, 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 tuk. Okay? But with the pen, I can say, okay, I will initiate my color to this color, and then I will say, okay, pen down. It is as if there was a pen attached to the feet of the cat. So if the pen is down, there is a trace on the ground. If the pen is up, there is no trace. So now, okay, I can change color each time if I want. I can say change color. There are 250 colors. It's not very spectacular, but if I say 15 here, I will do it faster. Okay? You can make a lot of geometry works. If you want to work in mathematics, for example, with Scratch, you can do a lot of geometry work. You can make triangles. But for triangles, you have to, let's say, take this angle. Oops. It's not a triangle. 30 triangle is only 3, of course. I don't know exactly what it is. You can clear if you want at the beginning of the program. It will be better if I ask him to come back to 0, 0, for example. Okay, and then pen up, clear, whoops. It's a bit, sorry, I have to pen up at the end. Well, it's not a triangle because I didn't choose well my angle here compared to the length. I have to, I can draw circles if I want, because here in operators I got a lot of possibilities. I can have sinus, cosinus, etc., etc. So I can make spirals, I can make a lot of things. Another possibility we didn't explore is the way Scratch is able to interact with the human. For example, here I can ask questions. I can say, okay, what is your name? And the answer will be automatically stored in a variable that already exists called answer. And here I will say, hello, sorry, I will say, so I have to say, but I don't want to say hello. I want to say hello, David, because my name is David. But if your name is not David, what is your name? David. Hello, David. Now, what is your name? Let's say Henri. Hello, Henri, etc., etc. You can ask to pupils to build their own evaluation form. For example, after a work in geography, you will say, what is the capital city of Malaysia? And then, if what? If answer equal Kuala Lumpur, Kuala Lumpur, say bravo. Oops. Say bravo. Else, say try again. Oops. So, what is the capital city of Malaysia? Let's say New York. Try again. Kuala Lumpur. Bravo. And I can create a variable with my score, and I can ask 20 questions, and each time I answer correctly, my score increases, and each time I make a mistake, my score don't move or decreases. I do what I want. Okay? You can make a lot. Scratch is very powerful. You can make a lot of things. You can make drawings, pictures, and so on. You can make games. You can manipulate variables. You can make some mathematics functions here. You can even create your own blocks. It's an advanced functionality of Scratch. So for just an initiation, I will not speak about it, but you can create your own blocks, etc., etc., etc. So you can build very advanced programs. I will show you just an example, something that I do with middle school classes. And after that, it will be the end. College, industry. We have a project for middle school class with cryptography. Cryptography, and I want to be able to analyze a text. Look at the program. It's quite huge. There are a lot of things. Everything here are blocks that I have defined. And now it will make an analyze of the frequency. What is the message to analyze? Let's say, hello everybody. And so it analyzes my text and it gives the frequency of each letter. And it draws the graphics and so on. And there are a lot of advanced functionalities hidden here. So just for you to realize that with Scratch you can do a lot of things, and not only games. You can make evaluation forms, you can make games, you can make mathematics, you can make geometry, you can make arts also. It's very powerful, and it is not so difficult to learn. It's quite intuitive. Of course, 2 or 3 hours is not enough. The purpose of this workshop was not to make you experts and become experts in Scratch, but just for you to discover that it exists, and this is very, very convenient to learn programming even for kids. So do you have any question before we end this work on computer sciences? If you don't have question, I think it's time to, yeah.
So you can also make, using that program, you can design activities, different subjects.
Yeah, you can build scientific simulations if you want. You can imagine that you have a sprite the sprite is one thermometer, another sprite is, let's say, meat, another sprite is a weight, another sprite is, a boiling box, and when you put you can weigh the meal, so see how many kilograms of meat you have and put it in the boiling water, see the evolution of temperature. You can do what you want. It's very powerful. You can design specific scientific activities. Here I have designed for high school teachers, high school children. It's a bit complicated, but it's a real physical simulation of a three-body problem. So you have 2 stars and 1 satellite, and you calculate the orbit, and here it crashes. And it's not a random drawing, it's real calculation with physical equations behind, etc. You can make general or relativity, you can do what you want because you have access to mathematical functions. So this is really powerful. Okay.